Hello everyone, I am Tanisha Gupta and today I will be presenting a complete overview of MongoDB, one of the most popular NoSQL databases used in modern applications. In this session, I'll walk you through its basics, features, architectures, and advanced concepts like replication, sharding, and MongoDB Atlas. Let's begin with the foundation. What is a database? A database is simply an organized collection of data that can be easily accessed, managed, and updated. Traditionally, we used relational databases like MySQL and PostgreSQL, which store data in tables and rows with a fixed schema. However, as applications grew more dynamic and started handling unstructured data like social media posts, IoT data, and sensor readings, we needed something more flexible. That's where NoSQL databases like MongoDB come in. There are two main types: relational, that is SQL, that are structured, table-based, and schema-defined. Second are non-relational, that are NoSQL, that are flexible, schema-less, and designed for scalability. MongoDB falls under the second category. It doesn't use tables or rows, but rather collections and documents, which makes it perfect for handling real-time and unstructured data. MongoDB is a NoSQL document-oriented database developed by MongoDB Inc. It's open source, cross-platform, and built for scalability and high performance. Instead of tables, it stores data in JSON documents, which allows a flexible schema. Internally, MongoDB uses BSON, that is binary JSON, a format that supports additional data types like object ID, date, and binary data. MongoDB stands out because of its amazing features that are schema-less design, that is, we can store data without defining a fixed schema in advance. It's high performance, that is ideal for reading and writing heavy applications. It has horizontal scaling, that is, it can be achieved using a concept called sharding. It has replication that ensures high availability and fault tolerance. It has aggregation framework that is used for complex data analysis within the database. It has powerful query language, that is, it makes it easy to filter, sort, and manipulate data. Now let's compare MongoDB with traditional SQL databases. SQL uses tables, whereas MongoDB uses collections. SQL has structured schemas, whereas MongoDB uses dynamic documents. MongoDB is best for large-scale, real-time, and unstructured data. For example, if we are building a social media app where every user's data structure might differ, MongoDB is much more flexible than MySQL. The architecture of MongoDB includes clients that sends queries, MongoDB server that handles database requests, Mongo's router for query routing, especially in sharding, and config servers that store metadata. This distributed architecture allows MongoDB to handle huge amounts of data efficiently. MongoDB organizes data into databases, collections that are similar to tables, and documents that are similar to rows but stored as JSON-like structures. Each document can have a different set of fields, which gives MongoDB its schema flexibility. MongoDB stores documents in BSON, which is a binary representation of JSON. BSON supports more data types and is faster to parse and store. So, while we see data as JSON, when we query it, it's actually stored in BSON internally. CRUD operations. So, CRUD stands for create, read, update, and delete, the four basic operations on any database. Examples: in insert, we use db.collection.insert1 and then write our query. In read, we use db.collection.find. In update, we use db.collection.update1 and then our query. And in delete, we use db.collection.delete1 and then our query. These operations form the foundation of working with MongoDB. Now, as we move forward with indexing, indexes are like shortcuts for faster searching. Without indexes, MongoDB scans every document, which can be very slow. So, we can create one using db.collection.createIndex and then field set to 1. But it's important to use them wisely, as too many indexes can slow down writes and consume more memory. Aggregation framework. So MongoDB's aggregation framework allows us to process data through multiple stages, similar to SQL's group by and aggregation functions. For example, if we do db.sales.aggregate, we can group ID with item and total sum with price. It's often used for generating reports or analyzing patterns directly within MongoDB. MongoDB supports relationships in two ways. That is embedding, which stores data inside one document that is good for one-to-one or one-to-few relationships. Second is referencing. It stores object IDs that reference data in another collection used for one-to-many relationships. We should embed if the data is frequently accessed together and reference if it's used often. MongoDB doesn't enforce a fixed schema, but design still matters. Some best practices are design according to application needs, avoid very large documents or arrays, use indexes wisely, combine embedding and referencing smartly for performance and scalability. MongoDB Atlas is a cloud-based version of MongoDB provided by MongoDB Inc. It offers automated backups, real-time monitoring, scalability. There's also a free tier for students and developers, perfect for testing and learning. Now we can also connect MongoDB with Node.js using the Mongo client, and client.connect functions. This is commonly used in web applications where Node.js handles the backend logic. Now, Mongoose is an object data modeling ODM library for MongoDB in Node.js. It simplifies defining schemas, data validation, and queries. We can use const user schema and new mongoose schema, then user is equal to mongoose.model to create a new mongoose schema. Mongoose helps us to apply structure while still using MongoDB's flexibility. Now MongoDB provides simple CLI tools like backup and restore. Backups are crucial for data safety and migration between servers. Replication ensures data availability and fault tolerance. A replica set consists of primary node that handles writes and secondary nodes that store copies of data. If the primary fails, one secondary automatically becomes the new primary, ensuring zero downtime. This is how MongoDB maintains reliability for mission-critical applications. Sharding. Sharding means splitting the data across multiple servers to achieve horizontal scalability. Each shard contains a subset of data and the Mongoose router directly queries to the right shard. Example, a large user database can be split by region. Shard 1 for Asia, Shard 2 for Europe, Shard 3 for America. This improves performance and load distribution. MongoDB supports ACID transactions since version 4.0, allowing atomic multi-document operations. This means we can perform multiple updates safely. Either all succeed or none of them are applied. Security is also critical. MongoDB provides authentication and user roles, SSL TLS encryption, regular backups, network access restrictions. These ensure data integrity and protection against unauthorized access. To sum it all up, MongoDB is fast, flexible, and scalable. It's ideal for real-time IoT and web applications. with features like replication, sharding, and atlas. It's a complete solution for modern data storage needs. Thank you for listening. I hope this session helped you a lot to understand MongoDB's core concepts and why it's such a powerful database for developers today. Thank you.